Hello, in this lecture we'll find out the radius of the biggest circle. In the drawing we have 4 circles. Those 3 circles are located inside the biggest circle. We know that the radius of this circle is equal to 4 units. The radius of this circle is equal to 9 units. And the radius of this circle, or the smallest circle, is equal to 1 unit. And we want to find out the radius of this circle that the 3 other circles are located in. Okay, so first of all, I will present to you 2 new theorems. The first theorem is the external lunge. When 2 circles are touching each other externally, like in this drawing, the point of contact between them is at point S. S is the point of tendency. We know that the center of this circle is at point M, and the radius of this circle is equal to small r. The center of this circle, of the big circle, is at point O, this point, and the radius of the big circle is equal to capital R. Then the distance between their centers, that is to say OM, is equal to capital R plus small r. So whenever you have an external lunge between 2 circles, then the distance between their centers will be equal to the sum of the lengths of their radii. In this case, it will be equal to capital R plus small r. This is the first type of tendency between 2 circles. Then we have also the second type of tendency between 2 circles, when the 2 circles are touching each other at one point internally. Then it is defined as internal lunge. Here the 2 circles are touching each other internally at point S. And here the distance between their centers is OM, and you can see it easily from the drawing that OM is equal to OS minus MS. So OS is capital R and MS is small r. So in conclusion, we found out that OM is equal to capital R minus small r. So we can, in conclusion, whenever 2 circles are touching each other internally, like in this drawing, that is the internal lunge, then the distance between their centers will be equal to the difference between the lengths of the radii. In this case, it will be equal to capital R minus small r, while if 2 circles are touching each other externally, like in this drawing, then the distance between their centers will be equal to the sum of the lengths of the radii. In this case, it will be equal to capital R plus small r. Okay? So here we will define the center of this circle, that its radius is equal to 4 units, as point A. We will define the center of this circle that its radius is equal to 9 units as point B, and we will define the center of this circle that its radius is equal to 1 unit as point C. Here, I didn't mention it in the beginning, but we have a straight line. This straight line is actually a tangent, that is tangent to those 3 circles at 3 different points. The first point of tendency is between this tangent and this circle at this point. We'll define the point of tendency of the straight line with this circle as point D. So D is the point of tendency of the straight line or the tangent with this circle. I write it down, point of tangency of this tangent with this circle. Likewise, we have here a second point of tangency. Here, this tangent to this circle at this point. We define the point of tendency, the second point of tendency, as point E. And here we have the first point of tendency of this tangent with the smallest circle. We define the point of tendency as point F. So we have 3 points of tendencies between this tangent with the 3 circles. We have point D, point E, and point F is the 3 points of tendencies of this tangent with those 3 circles. In the next step, we will join points A and D together by a straight line. What is line segment AD? Line segment AD is the radius of this circle. Why? Because line segment AD starts from the center of this circle, and that's at point D, that is a point of this circle itself. And this is definition, that is exactly the definition of a radius. Therefore, AD equals to 4 units as the radius of this circle. Likewise, we will join points B and D together by a straight line. Again, here BE is the radius of this circle because of the fact that it starts from the center of the circle, and then at point E, that is the point of the circle itself. Therefore, BE is the radius of this circle, that is to say, it equals to 9 units. Here BE equals to 9 units as the radius of this circle. We'll join point C and F together by a straight line. Again, here CF is the radius of this circle because of the fact that it starts from the center of the circle and ends at point F. That is the point of this circle itself. Therefore, CF is the radius of this circle, that is to say it equals to 1 unit. In the next step, I will present to you a new rule that is actually rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So I read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we will implement rule number 1 in our drawing. Here we have the radius AD of this circle, it is drawn to the point of tendency, that is to say it is drawn to point D, that is the point of tendency of this tangent with this circle. Therefore, according to rule number 1, the tangent FD will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we have the radius BE that is drawn to the point of tendency. That is to say, it is drawn to point E, that is the point of tendency of this tangent with this circle. Therefore, the tangent FD will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we have the radius CF that is drawn to the point of tendency, that is to say, it is drawn to point F, that is the point of tendency of tangent DF with this circle. Therefore, the tangent DF will be perpendicular to this radius, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? In the next step, we will define the center of the biggest circle, the center of this circle as point O, and we will define the radius of the biggest circle as capital R. I write it here that capital R is equal to the radius of the biggest circle. Okay? In the next step, we will draw perpendicular from point A to BE. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We will define the touching point between the perpendicular from point A to BE as point P, and we will focus on quadrilateral AD. We will focus on quadrilateral ADPE. In quadrilateral ADPE, we have here 3 right angles, 1, 2, 3, and the sum of 3 right angles is equal to 90 times 3 is 270 degrees. 270 degrees plus the size of this angle, that is actually angle DAP. In total, the sum of those 4 angles, must be equal in total to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We will subtract 270 degrees from this equation and we will get that the size of angle DAP is equal to 360 degrees minus 270 degrees is equal to 90 degrees. So angle DAP is a right angle. Get right there. That angle DAP is equal to 90 degrees. And because of the fact that quadrilateral APDE has 4 right angles, we can conclude from it that quadrilateral ADPE is a rectangle. I write it down. Quadrilateral ADPE is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. The opposite sides this will be rule number 2, that the opposite sides of a rectangle are equal to each other. So according to rule number 2, that states that the opposite sides of a rectangle are equal to each other, AD will be equal to PE. AD will be equal to PE. But we know that AD is the radius of this circle that is equal to 4 units. AD equals to 4 according to what is given us in the question. And from this equation 4 equals to AD equals to PE, we will conclude that PE is also equals to 4 units. PE is also equals to 4 units. So write here that PE is equal to 4 units. In the next step, from point O, we will go perpendicular to DE. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees, and we will define the touching point of the perpendicular from point O to DE as point M. And we also will define the intersection point between line segment OM and AP as point S. And we will focus on quadrilateral ASDM. and quadrilateral ASDM we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees plus the size of this angle. This is actually angle ASM. In total, the sum of those 4 angles must be equal in total to 360 degrees. Here we'll subtract 270 degrees from this equation and we'll get that 360 degrees minus 270 degrees equals to 90 degrees. So we found out that angle ASM is a right angle. It is equal to 90 degrees. So we can write here that this angle is a right angle. And because of the fact that quadrilateral ASDM has 4 right angles, we conclude that quadrilateral ASDM is a rectangle. Quadrilateral ASDM is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, AD equals to SM. That is according to rule number 2. But AD equals to 4 units. It is the radius of the circle. So from this equation 4 equals to AD equals to SM, we conclude that SM is also equal to 4 units. SM is also equal to 4 units. And we'll focus on quadrilateral SPME. In quadrilateral SPME, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this angle, that is actually angle MSP. In total, the sum of those 4 angles, they must be equal in total to 360 degrees. Again, 270 degrees plus the size of angle MSP must be equal in total to 360 degrees. We will subtract 270 degrees from this equation and we will get that angle MSP is equal to 90 degrees. So this angle is a right angle, that is to say it equals to 90 degrees. And because of the fact that quadrilateral SPME has 4 right angles, we conclude that quadrilateral SPME is a rectangle. Quadrilateral SPME ME is a rectangle. So actually we found out that all the three quadrilaterals here, quadrilateral SASTM, quadrilateral SPME, and quadrilateral APTE are all rectangles, and we know what is the size of line segment BP. You can see it from the drawing that BP equals to BE minus PE. BP equals to BE minus PE. So actually BP equals to BE that equals to 9 units minus PE that equals to 4 units. So in conclusion, we found out that BP equals to 9 minus 4. 9 minus 4 is 5. So we can write down that BP equals to 5 units. BP equals to 5 units. We can write here that BP equals to 5 units. In the next step, we will join points A and B together by a straight line. What is the value of AB? The value of line segment AB. We know that A is the center of this circle, that its radius is equal to 4 units. B is the center of this circle, that its radius is equal to 9 units. Those two circles have an external length between them at this point, that is to say they are touching each other at this point, and whenever we have two circles that have an external length between them, then the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, the radius of this circle is equal to 4 units, the radius of this circle is equal to 9 units, and the sum of the lengths of their radii will be equal to 4 plus 9, that is to say, it will be equal to 13 units. So we found out that AB equals to 13 units. You can write here that AB equals to 13 units. We have already found out that BP equals to 5 units. So we will implement the Pythagoras theorem on the right triangle, triangle ABP. So in the right triangle, triangle ABP, according to the Pythagoras theorem, here the letters P and T are abbreviation for Pythagoras theorem. So here, according to the Pythagoras theorem on the right triangle, triangle ABP, we will get that AB squared is equal to BP squared plus AP squared. I'll repeat again, in the right triangle ABP, according to the Pythagoras theorem, AB squared equals to BP squared plus AP squared. A, here, we found out that AB equals to 13 units. So AB squared is 13 squared is 169. It equals to BP squared. BP is equal to 5, so BP squared is 5 squared is 25. Plus AP squared. So actually, in conclusion, we found out that 169 equals to 25 plus AP squared. Here we subtract 25 from this equation, and we find out that 165 minus 29 is 144. 144 equals to AP squared. Here we take a root out of this equation, and we'll find out that AP is equal to the square root of 144, and the square root of 144 is 12. So we found out that AP equals to 12 units. So we can write here that AP is equal to 12 units. And because of the fact that quadrilateral APDE is a rectangle and the opposite sides of a rectangle are equal to each other, we conclude that AP equals to DE. So in rectangle APDE, we know that AP is equal to DE. I repeat again, in rectangle APDE, we know that AP equals to DE according to the rule that the opposite sides of a rectangle are equal to each other. But we just right now found out that AP equals to 12 units. So from this equation, 12 equals to AP equals to DE, we will conclude that DE is also equals to 12 units. So we can write here that DE and segment DE is equal to 12 units. Okay. We will define ME as X, that is to say ME equals to X according to our definition. And what will be the value of DM? can see it easily from the drawing that dm equals to de minus me. Equals to de minus me. I'll repeat again. dm equals to de minus me. So dm is equal to de, that is equal to 12 units, minus dm, that is equal to x. So in conclusion, we found out that dm is equal to 12 minus x. So we can write here that dm is equal to 12 minus x. And because of the fact that quadrilateral ASDM is a rectangle, so in rectangle ASDM, the opposite sides are equal to each other. That is to say, dm is equal to as. I will repeat again. In rectangle ASDM, the opposite sides are equal to each other. That is to say, dm equals to as. But we have already found out that dm equals 12 minus x. So we can write here that dm is equal to 12 minus x. And from this equation, 12 minus x equals to dm equals to as, we will conclude that as is also equals to 12 minus x. as is also equals to 12 minus x. So we can write here that as equals to 12 minus x. Likewise, in rectangle SPME, the opposite sides are equal to each other. Rectangle SPME, the opposite sides are equal to each other. That is to say, SP equals to ME. SP is equal to ME. I'll repeat again. In rectangle SPME, the opposite sides are equal to each other. That is to say, SP equals to ME. But ME is equal to X according to our definition. ME is equal to X. And from this equation, we derive that SP also equals to X. SP is also equals to X. So we can write here that SP equals to X. In the next step, we will focus. Here we have OM. OM is the perpendicular from point O to DE. So OM as a perpendicular, it is absolutely a straight line. OM is a straight line. Okay, so line segment OM is a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So I write it down. Maybe rule number 3. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. I'll repeat again on rule number 3. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line OM at point S, then the sum of the angles must be equal to 180 degrees. So which angles we have at point on this side of the straight line OM at point S? We have here 90 degrees plus this angle that is actually angle OSA. So I can write down that 90 degrees plus the size of angle OSA, in total they must be equal to 180 degrees according to rule number 3. Here we'll subtract 90 degrees from this equation and we'll get that the size of angle OSA is equal to 180 degrees minus 90 degrees, that is to say it equals to 90 degrees. So we found out that this angle is a right angle, it equals to 90 degrees, so we can write down that this angle is a right angle, angle OSA. And because of the fact that angle OSA is a right angle, then triangle OSA is a right triangle. Okay, you can also write down that triangle OSA is a right triangle. So we'll focus on the right triangle, triangle OSA. But we'll find out also the length of line segment AO. What is the length of line segment AO? A is the center of this circle that its radius is equal to 4 units. O is the center of the biggest circle that its radius is equal to capital R. And this circle and the biggest circle have an internal length between them at this point, that is to say they are touching each other at this point. And any two circles that have an internal length between them, then the difference between the length of their radiuses will be equal to the difference between the distance between their centers, that is to say AO, will be equal to the difference between the lengths of the radii. the radius of this circle is equal to 4 units, the radius of the biggest circle is equal to capital R, and the difference between the radii will be equal to capital R minus 4. So we found out that O equals to capital R minus 4. In the next step, so AO equals to capital R minus 4. In the next step, I will draw the right green triangle, triangle AOS in a new page, and we will implement the Pythagoras theorem on the right triangle, triangle AOS. The green right triangle, triangle AOS. So here, so this is the right triangle, triangle AOS. Actually, we defined line segment OM as Y. That is to say, OM is equal to Y according to our definition. And so what is the value of OS? You can see it easily from the drawing that OS is equal to OM minus SM. Again, OS equals to OM minus SM. Equals to OM minus SM. So OS is equal to OM, that is Y according to our definition, minus SM, that equals to 4. So in conclusion, we found out that OS equals to Y minus 4. Now we can implement the Pythagoras theorem on the right triangle, triangle OAS. So in the right triangle, triangle OAS, according to the Pythagoras theorem, I will remind you that PT is abbreviation for Pythagoras theorem, the letters P and T. According to the Pythagoras theorem, this will be equation number 1. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AO, so the square of the hypotenuse is AO squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OS squared plus AS squared. So actually, in triangle OAS, according to the Pythagoras theorem, AO squared equals to OS squared plus AS squared. So according to equation number 1, AO is R minus 4, so AO squared is R minus 4 squared. And it equals to OS. OS is Y minus 4, so OS squared, it equals to OS squared, so OS squared is Y minus 4 squared plus AS squared. AS equals to 12 minus X, so AS squared will be equal to 12 minus X squared. So R minus 4 squared is equal to R squared plus 16 minus 8R. That equals to Y minus 4 squared. Y is equal Y, so Y minus 4 squared equals to Y squared plus 16 minus 8Y plus 12 minus X squared. 12 minus X squared equals to 12 squared, that is actually equals to 144 plus X squared minus 24X. Here we have 16 on both sides of equation number 1, so 16 will get cancelled. We will subtract 8, we will add 8R to this equation, equation number 1, and we'll get that according to equation number 1, R squared equals to 8R minus 8Y plus 144 minus 24X plus X squared plus Y squared here we take a common factor of 8 out of those two expressions, and we will get that R squared is equal to 8, in the brackets we have R minus Y plus 144 minus 24X plus X squared plus Y squared. We subtract X squared and Y squared from this equation, equation number 1, and we will get that according to equation number 1, R squared minus X squared minus Y squared is equal to 8 times R minus Y plus 144 minus 24X. So this is equation number 1, and according to equation number 1, R squared minus X squared minus Y squared equals to 8 times R minus Y plus 144 minus 24X. So in the next step, we will draw perpendicular from point O to BE. So this angle equals to 90 degrees. and this angle will be also equal to 90 degrees. And we will define the touching point between the perpendicular from point O to BE is point T. So I will copy the right triangle OBT in a new page, and we will implement the Pythagoras theorem on this triangle OBT. Okay, so here ME But first of all, we will find out the value of line segment OB O is the center of the biggest circle, that is radius is equal to capital R. B is the center of this circle, that its radius is equal to 9. And the biggest circle and this circle have an internal notch between them at this point, that is to say they are touching each other at this point. And whenever we have two circles that are touching each other internally, then the distance between their centers, that is to say OB, will be equal to the difference between the lengths of the radii. The length of the radii, well, the length of the radius of the biggest circle is equal to capital R. The length of the radius of this circle is equal to 9, and the difference between the radii will be equal to R minus 9. So here OB equals to R minus 9. And in quadrilateral OMTE, we have three right angles, 1, 2, 3. The sum of three right angles is 270 degrees. 270 degrees plus the size of this angle, that is actually angle MOT. In total, the sum of those four angles, they must be equal to 360 degrees. We will subtract 230 degrees from this equation, and we will get that the size of angle MOT is equal actually to 90 degrees. So we found out that this angle is a right angle, that is to say it equals to 90 degrees. Therefore, quadrilateral MOTE, that is 4 right angles, is a rectangle. Write it down, quadrangle OTME is a rectangle, and we know that the opposite sides of a rectangle are equal to each other according to rule number 2, and that is to say ME is equal to OT, ME is equal to OT, but ME equals to X according to our definition. So from this equation, X equals to ME equals to OT, we will get that, we derive that OT is also equal to X. So we found out that OT equals to X, and we know, according to our definition, OM is equal to Y. We know that OM is equal to Y according to our definition, and the opposite sides in rectangle OTME are equal to each other. That is to say, OM is equal to TE, OM is equal to TE, but OM is equal to Y according to our definition. So we can write down that OM equals to Y, and from this equation Y equals to OM equals to TE, we will derive that TE is also equals to Y. TE is equal to Y. And BE is the radius of this circle, that is to say it equals to 9 units. Here BE equals to 9 units. So what is the value of BT? The value of line segment BT, you can see it easily from the drawing that BT is equals to BE minus TE. BE minus TE, BE minus TE is equal to BT. That is to say, BT is equal to BE, that is 9 units, minus TE, that is Y. So in conclusion, we found out that BT equals to 9 minus Y. So we can write here that BT equals to 9 minus Y. So now we can implement the Pythagoras theorem on this green right triangle OBT. According to the Pythagoras theorem, in the green right triangle, OB square will be equal to BT square plus OT square. So OB square is R minus 9 square and it is equal to BT square, that is 9 minus Y square plus OT square, that is actually X square. So in conclusion, we found out that according to equation number 2, R minus 9 square is equal to 9 minus Y square plus X square. Here we will open the brackets on both sides of equation number 2, and we will get that R minus 9 square is equal to R square plus 81 minus 18 R, that equals to Y minus 9 square. Y minus 9 square equals to, it is actually 9 minus Y square. 9 minus Y square equals to 81 plus Y square minus 18Y plus X square. Here we have 81 on both sides of equation number 2, so 81 will get cancelled. We will add 18r to this equation number 2. And we get that according to equation number 2, r squared equals to 18r minus 18y plus x squared plus y squared. Here we will subtract x squared and y squared from this equation number 2, and we get that according to equation number 2, r squared minus x squared minus y squared is equal to, here 18r, we take out 18 as a common factor out of those two expressions, and we get that it is equal to 18 r minus y. So in conclusion, we found out that according to equation number 2, r squared minus x squared minus y squared equals to 18 times r minus y. In the next step, from point C, we will draw perpendicular to BE. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. We will define the touching point of the perpendicular from point C to BE as point Q. And we will focus on quadrilateral QCEF. On quadrilateral QCEF, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of the fourth angle, that is actually angle QCF. In total, the sum of those 4 angles must be equal in total to 360 degrees. Here we will subtract 270 degrees from this equation, and we will get that the size of angle QCF is actually equals to 360 degrees minus 270 degrees, that is to say it equals to 90 degrees. So we found out that this angle is a right angle equals to 90 degrees. So for quadrilateral QCEF that has 4 right angles, it is a rectangle. Quadrilateral QCEF is a rectangle. And we know that the opposite sides of a rectangle are equal to each other according to rule number 2. And so that is to say QE is equal to CF. QE is equal to CF, but we know that CF equals to 1 unit. It is the radius of the smallest circle. CF is equal to 1 unit. From this equation, Q equals to CF equals to 1, we will conclude that QE is also equals to 1. Here we can write down that QE is equal to 1. In the next step, we will join points B and C together by a straight line. What is the length of line segment BC? The length of line segment BC, we know that B is the center of this circle, that its radius is equal to 9 units. C is the center of the smallest circle, that its radius is equal to 1 unit. And those two circles have an external notch between them, that is to say, they are touching each other externally, they are tangent to each other externally. At this point, again, those two circles have an external notch between them at this point. That is to say, they are touching each other externally at this point. And then in two circles that are touching each other externally, then the distance between their centers is equal to the sum of the lengths of their radii. The radius of this circle is equal to 9 units. The radius of the smallest circle is equal to 1 unit. And the sum of the lengths of their radii is equal to 9 plus 1, that is to say it equals to 10 units. So we found out that BC equals to 10 units. In the next step, I will copy the right triangle BQC in a new page, and we will implement the Pythagoras theorem on the right triangle BQC. We have already found out that quadrilateral QCEF, this quadrilateral is a rectangle, and the opposite sides of a rectangle are equal to each other. So here we will focus on the right triangle PQC. We know that the hypotenuse BC is equals to 10 units. So what is the value? And we also know that BE is the radius of this circle that is equal to 9 units. B equals to 9 units. So what is the value of side QB? QB, you can see it easily from the drawing. The BQ is equals to BE minus QE. Is equals to BE, that is the radius of the circle, minus QE. That is to say QB is equals to BE, that is the radius of the circle that equals to 9 units, minus QE that is equal to 1. So in conclusion, we found out that QB equals to 9 minus 1. That is to say QB is equal to 8 units. Here QB is equal to 8 units. So now we can implement the Pythagoras theorem on the right triangle, the right green triangle, triangle QBC. According to the Pythagoras theorem, BC square, the square of the hypotenuse is equal to the sum of the square of the perpendiculars. That is to say, BC square will be equal to BQ square plus QC square. So we found out that BC equals to 10, so BC square is 10 square, 10 square is 100, that equals to BQ square. BQ equals to 8, so BQ square is 8 square, 8 square is 64, plus QC is the missing side, so plus QC square. So in conclusion, we found out that 100 equals to 64 plus QC square. We'll subtract 64 from this equation. 100 minus 64 is 36, so 36 equals to QC square. Here we will take a root out of this equation and we'll find out that QC is equals to the square root of 36. The square root of 36 is 6. So we found out that QC equals to 6 units. And because of the fact that the opposite sides of rectangle QCEF are equal to each other, we conclude that QC is equals to EF. But we just right now found out that QC equals to 6 units. So from this equation 6 equals to QC equals to EF, we conclude that DEF is also equals to 6 units. So we can write here that EF equals to 6 units, and also here so in the next step, we will join from point C, we will draw perpendicular to OM. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees, and we'll define the touching point of the perpendicular from point C to OM as point U, and actually UCMF is a rectangle because of the fact that all of its sides, all of its angles are right angles. So you can write down that quadrilateral UCMF is a rectangle. Quadrilateral UCMF is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. that is to say UC is equal to UM, or CF is equal to UM, CF is equal to UM, but CF is equal to 1 unit. CF is the radius of this small circle is equal to 1 unit. From this equation, 1 equals to CF equals to UM, we will conclude that UM is also equals to 1 unit. Here UM is equal to 1 unit. In the next step, we will join points O and C together by a straight line. So what is the length of side OC, or the length of line segment OC? O is the radius O is the center of the biggest circle, that its radius is capital R. C is the center of the smallest circle, that its radius is 1 unit. And those two circles, the biggest circle and the smallest circle, they have an internal notch between them at this point, that is to say they are touching each other at this point internally. And then in two circles that are touching each other internally, then the distance between their centers, that is to say OC, will be equal to the difference between the lengths of their radii. The radius of the biggest circle is equal to capital R. The radius of the smallest circle is equal to 1. And the difference between the radii will be equal to capital R minus 1. So we found out that OC is equal to capital R minus 1. In the next step, I will copy the right triangle, triangle OUC, in a new page, and we will implement the Pythagoras theorem on this green right triangle, triangle OUC. So we know this is the right triangle, triangle OUC. We know that quadrangle UCMF is a rectangle, so in rectangle UCMF, the opposite sides are equal to each other. That is to say, UC is equal to MF. But we already found out that MF is equal to x plus 6. From this equation, UC equals to MF equals to x plus 6. We will conclude that UC is also equals to x plus 6. UC is also equals to x plus 6. And what is the value of OU? First of all, according to our definition, OM is equal to Y. According to our definition, OM is equal to Y. OM is equal to Y. According to our definition. You can see it easily from the drawing that OU is equal to OM minus UM. Again, OU equals to OM minus UM. That is to say, OU is equal to OM, that is Y, minus UM, that is 1. So in conclusion, we found out that OU is equals to Y minus 1. So now we can implement the Pythagoras theorem on the right green triangle, triangle OUC. So in the right triangle, triangle OUC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC squared will be equal to OU squared plus UC squared. Again, according to the Pythagoras theorem, in the right triangle, triangle OUC, OC squared will be equal to OU squared plus UC squared. OC equals to R minus 1, so OC squared is R minus 1 squared. OU equals to Y minus 1, so OU squared will be equal to Y minus 1 squared plus UC squared. UC equals to X plus 6, so UC squared will be equal to X plus 6 squared. Here we open the brackets on both sides of this equation, equation number 3, and we will get that R minus 1 squared is equal to R squared plus 1 minus 2R, that equals to Y minus 1 squared. Y minus 1 squared is equal to Y squared plus 1 minus 2Y plus X plus 6 squared equals to X squared plus 36 plus 12X. So here we have 1 on both sides of equation number 3, so 1 will get cancelled, and we will add 2R to this equation, equation number 3, and we will get that according to equation number 3, R squared equals to 2R minus 2Y plus 36 plus 12X plus X squared plus Y squared. Here we'll subtract x squared and y squared from this equation number 3, and we'll get that r squared minus x squared minus y squared equals to, here 2r minus 2y, we'll take a common factor of 2 out of those two expressions, and we'll get that it is equal to 2 times r minus y plus 36 plus 12x. So in conclusion, we found out that according to equation number 3, r squared minus x squared minus y squared equals to 2 times r minus y plus 36 plus 12x. In the next step, we will copy the 3 equations in one page, and we will solve those 3 equations in order to find out the value of x, y, and capital R, that is the value, the variable that we are looking for, the radius of that is actually the radius of the biggest circle that we are looking for. So we get that according to equation number 3, r squared minus x squared minus y squared equals to 2 times r minus y plus 36 plus 12x. And according to equation number 2, r squared minus x squared minus y squared equals to 18 times r minus y. And we already found out that according to equation number 1, r squared minus x squared minus y squared is equal to 8 times r minus y plus 144 minus 24x. In the next step, we will create equation number 4, which states that r squared minus x squared minus y squared according to equation number 1, that is actually equals to 8 times r minus y plus 144 minus 24x, it must be equal to r squared minus x squared minus y squared according to equation number 2, that is actually equals to 18 times r minus y. So here we will subtract r 8 times r minus y from this equation number 4, and we will get that according to equation number 4, Hundred 44 minus 24x equals to 10 times r minus y. Here we will divide the equation number 4 by 10, and we will get that according to equation number 4, r minus y is equal to 144 minus 24x over 10. Here we will divide both the numerator and the denominator of equation number 4 by 2, and we will get that according to equation number 4, r minus y is equal to 144 over 2 is 72, minus 24x over 2 is minus 12x, and 10 over 2 is 5. So we found out that according to equation number 4, r minus y equals to 72 minus 12x over 5. In the next step we create equation number 5 that states that r squared minus x squared minus y squared according to equation number 5, that is according to equation number 3, that is actually 2 times r minus y plus 36 plus 12x. It must be equal to r squared minus x squared minus y squared according to equation number 2, that is actually 18 times r minus y. So here we'll subtract 2 times r minus y from this equation number 5, and we'll get that 36 plus 12x is equal to 16 times r minus y. Here we'll divide equation number 5 by 16, and we'll get that according to equation number 5, r minus y is equal to 36 plus 12x over 16. Here we will divide both the numerator and the denominator of this side of equation number 5 by 4, and we get that according to equation number 5, r minus y is equal to 36 over 4 is 9, 12x over 4 is 3x, 16 over 4 is 4. So we found out that according to equation number 5, r minus y equals to 9 plus 3x over 4, while according to equation number 4, we've already found out that r minus y is equal to 72 minus 12x over 5. In the next step, we'll create equation number 6. Equation number 6 states that r minus y according to equation number 5, that is actually equals to 9 plus 3x over 4, must be equal to r minus y according to equation number 5, that is equal to 72 minus 12x over 5. This is equation number 6. So here we'll cross multiply equation number 6, and we'll get that according to equation number 6, 5 times 9 plus 3x will be equal to 4 times 72 minus 12x. We will open the brackets on both sides of equation number 6, and we'll get that according to equation number 6, 5 times 9 is 45, plus 5 times 3x is 15x. That equals to 4 times 72 is 188. 4 times minus 12x is minus 48x. Here we'll subtract 45 from this equation number 6, and we'll get that 288 minus 45 is 243. That equals to 48x plus 15x is 63x. Here we will divide equation number 6 by 9, and we'll get that according to equation number 6, 63 over 9 is 7, so 7x is equals to 243 over 9 is 27. Here we'll divide equation number 6 by 7, and we'll get that according to equation number 6, x is equals to 27 over 7. We have already found out that according to equation number 5, r minus y is equal to 9 plus 3x over 4. So now we will put the value of x in equation number 5, and we get that according to equation number 5, r minus y is equal to 9 plus 3x, and x equals to 27 over 7, all divided by 4. Here 3 times 27 is 81, so we get that r minus y is equal to 9 plus 81 over 7 over 4. Here we will multiply 9 by 7, and then we will divide it by 7 in order to have a common factor with 81 over 7, and we will get that according to equation number 5, r minus y is equal to 9 times 7 is 63 plus 81 over 7 over 4. Here 7 times 4 is 28, so according to equation number 5, we will get that 63 plus 81 is 144. 4 times 7 is 28. Here we will divide both the numerator and the denominator on this side of the equation number 5 by 4. 144 over 4 is 36, and 28 over 4 is 7. So in conclusion, we found out that according to equation number 5, r minus y is equal to 36 over 7, and we have already found out that according to equation number 6, x equals to 27 over 7. We have equation number 2. According to equation number 2, r square minus x square minus y square is equal to 18 times r minus y. But we know that r square minus y square is equal to r plus y times r minus y, according to the algebraic identity that a square minus b square equals to a square equals to a plus b times a minus b, equals to x squared plus 18 times r minus y. So here we will substitute in equation number 2 r minus y by 36 over 7, and we will substitute x by 27 over 7, so, and we will get that r plus y times r minus y is 36 over 7, that equals to x squared. X is 27 over 7, so x squared will be equal to 27 over 7 squared. Again, r minus y is 36 over 7. Here we will multiply equation number 2 by 7, and we will get that according to equation number 2, r plus y times 36 is equals to 27 times 27 over 7 plus 18 times 36. Here we will divide equation number 2 by 4, and we will get that 36, we will divide equation number 2 by 9, and we get that 36 over 9 is 4, so according to equation number 2, we will get that 4 times r plus y is equals to 27 over 9 is 3, so we have 3 times 27 over 7 plus 18 over 9 is 2, and 2 times 36 is 72. So here we get that according to equation number 2, 4 times r plus y is equals to 3 times 27 is 81, and we'll multiply 72 by 7, and then we'll divide it by 7. So according to equation number 2, 4 times r plus y is equals to 81 plus 7 times 72 is 504 over 7. 81 plus 504 is 585 over 7. That equals to 4 times r plus y. Here we will divide the equation number 2 by 4, and we will get that r plus y is equal to 585 over 7 times 4 is 28. But according to equation number 5, we have already found out that r minus y is equals to 36 over 7. Here we will multiply both the numerator and the denominator of this side of the equation number 5 by 4, and we will get that 4 times 36 is 144, and 7 times 4 is 28. So in conclusion, we found out that according to equation number 5, r minus y equals to r minus y is equals to 144 over 28. This is according to equation number 5. While according to equation number 2, we have already found out that r plus y is equal to 585 over 28. So here we will add equation number 2 to equation number 5, and we will get that r plus r equals to 2r, and y plus minus y, it is actually equals to y minus y, that is 0, and it equals to 585 over 28 plus 144 over 28. And so we got that 2r is equal to 185 plus 585 plus 144 is 729 over 28. Here we'll divide this equation by 2, and we'll get that the radius of the biggest circle is equals to 729 over 2 times 28 is 56. So in conclusion, we found out that the radius of the biggest circle is equal to either 729 over 56 units, or we can present it also as 13.018 units. So I repeat again, we found out that the radius of the biggest circle is equal to either 729 over 56 units, or we can present it as that the radius of the biggest circle equals to 13.018 units. In the next step I will summarize the lecture. Actually, we wanted to find out the radius of this, the biggest circle. We have here two circles that are located inside the biggest circle, and we want to find out the radius of the biggest circle. So here we know that the radius of this circle is equal to 4 units, the radius of this circle is equal to 9 units, the radius of the smallest circle is equal to 1 unit, and we want to find out the radius of the biggest circle that the 3 other circles are located inside it. So first of all, I presented to you a new theorem that is actually the external lunge. When two circles are touching each other, they can touch each other in two different ways. The first type of touching, or the first type of tendency between two circles, is the external lunge. The external lunge is when the two circles are touching each other externally. Here the two circles are touching each other externally at point S. S is the point of tendency between those two circles. They are touching each other at point S, and the distance between their centers, that is to say OM, is equal to capital R plus small r. So in conclusion, we can say that whenever two circles are touching each other externally, like in this case, that is the external lunge, the case of the external lunge, then the distance between their centers, that is to say OM, will be equal to the sum of the lengths of the radii, that is to say, in this case, it will be equal to capital R plus small r. This is the first type of tendency between two circles, and the second type of tendency between two circles is that when the two circles are touching each other internally, that is to say, that is the internal lunge. In the internal lunge, the two circles are touching each other internally at this point, point S, and the distance between their centers, that is to say OM, will be equal to the difference between the lengths of their radii. In this case, it will be equal to capital R minus small r. So whenever two circles are touching each other internally, that is the internal lunge, then the distance between their centers will be equal to the difference between the lengths of the radii, that is to say, it will be equal, in this case, to capital R minus small r. Then we define the center of this circle as point A, the center of this circle as point B, and the center of this circle as point C. We have here a straight line that is tangent to this circle as point D. The straight line is tangent to this circle as point E, and the straight line is tangent to this circle as point F. We joined points A and D together by a straight line. AD is the radius of this circle. Why? Because it starts from the center of this circle at point and ends at point D. That is the point of this circle itself. Therefore, line segment AD is the radius of this circle, that is to say, it equals to 4 units. We join points B and D together by a straight line. BE is the radius of this circle, that is to say, it equals to 9 units. We join points C and F together by a straight line. CF is the radius of this circle, that is to say, it equals to 1 unit. Then I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have the radius AD is drawn to the point of tendency, that is to say, it is drawn to point D, that is the point of tendency of tangent FD with this circle. Therefore, according to rule number 1, the tangent FD will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Likewise, we have the tangent BE that is drawn to the point of tendency. That is to say, we have the radius BE that is drawn to the point of tendency. That is to say, the radius BE is drawn to the point E, that is the point of tendency of tangent FD with this circle. Therefore, according to rule number 1, the tangent FD will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Likewise, here, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees according to rule number 1. Then we join points A. From point A, we draw perpendicular to BE. So this angle equals to 90 degrees and this angle equals to 90 degrees. We define the touching point of the perpendicular from point A to BE as point P. Then we focus on quadrilateral ADPE. In quadrilateral ADPE, we have 3 right angles, 1, 2, 3. And the sum of 3 right angles is equal to 270 degrees. So 270 degrees plus the size of the 4th angle, that is actually angle DAP. In total, the sum of those 4 angles must be equal to 360 degrees. We subtracted 270 degrees from this equation and we got that angle DAP equals to 90 degrees. So this angle is a right angle, therefore quadrilateral APDE has 4 right angles, and therefore quadrilateral ADPE is a rectangle according to the rule, and we know that the opposite sides of a rectangle are equal to each other. Rule number 2 states that the opposite sides of a rectangle are equal to each other. That is to say, AD equals to PE. AD equals to PE according to rule number 2, but AD equals to 4 units. So from this equation, 4 equals to AD equals to PE, we will conclude that PE is also equals to 4 units. Then we focused on quadrilateral ACDM. In quadrilateral AC, but before that, from point O, we draw perpendicular to DE. So this angle equals to 90 degrees and this angle equals to 90 degrees. And we define the touching point of the perpendicular from point O to DE as point M. And then we focused on quadrilateral ASDM, and this quadrilateral we have 3 right angles, 1, 2, and 3, and the sum of 3 right angles is equal to 270 degrees, so 270 degrees plus the size of angle ASM. It is actually plus the size of angle SAM, SAD. We have actually here 1, 2, 3 right angles. 1, 2, 3 right angles. So the sum of 3 right angles is 270 degrees plus the size of this angle that is actually angle ASM. In total, the sum of those four angles must be equal to 360 degrees. Here we subtracted 270 degrees from this equation and found out that angle ASM, this angle is a right angle. It equals to 90 degrees. So actually we found out that in quadrilateral ASDM we have four right angles. And therefore quadrilateral ASDM is a rectangle. Quadrilateral ASDM is a rectangle, and we know that the opposite sides of a rectangle are equal to each other according to rule number 2. That is to say AD equals to SM. AD equals to SM according to rule number 2, but AD equals to 4 units. So from this equation 4 equals to AD equals to SM, we will conclude that SM is also equals to 4 units, so here SM equals to 4 units. Here quadrilateral SPME, quadrilateral SPME has three right angles. Actually here we have 1, 2, 3 right angles, and the sum of three right angles is 270 degrees, so 270 degrees plus angle MSP plus this angle, in total the sum of those four angles must be equal to 360 degrees in quadrilateral SPME. Here we subtracted 270 degrees from this equation and we found out that angle MSP, this angle is equal to 90 degrees. Therefore, quadrilateral SPME has four right angles, and therefore quadrilateral SPME is a rectangle. Quadrilateral SPME is a rectangle, and what is the value of BP? From the drawing, it is very easy to see that BP equals to BE minus EP. BP equals to BE minus EPE. So BP equals to BE, that is 9 units, minus PE, that is 4 units. So we found out that BP equals to 9 minus 4 is 5. So we found out that BP equals to 5 units. Then we join points A and B together by a straight line. So what is the value of line segment AB? A is the center of this circle that its radius is equal to 4 units. B is the center of this circle that its radius is equal to 9 units. So AB, that is the distance between the centers. So actually those two circles have an external length between them, that is to say they are touching each other externally at this point. This is the point of tendency between those two circles, and whenever you have two circles that have an external length between them, then the distance between their centers will be equal to the sum of the lengths of the radii. And the radius of this circle is 4 units, the radius of this circle is 9 units, and the sum of the lengths of the radii will be equal to 4 plus 9, that is 13. So we found out that AB equals to 13 units. We found out also that we already found out that BP equals to 5 units. So we focus on the right triangle ABP. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square will be equal to BP square plus AP square. AB square equals to BP square plus AP square. AB equals to 13, so AB square is 13 square. 13 square is 169, and it will be equal to BP square. BP equals to 5, so BP square is 5 square. 5 square is 25 plus AP square. Here we subtracted 25 from this equation, and we found out that 169 minus 25 is 124. So we got that 124 equals to AP square. We took out of this equation and we found out that AP equals to the square root of 124, and the square root of 124 is equal to 12. So we found out that AP equals to 12 units. And we have APDE is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, AP is equal to DE. Again, APDE is a rectangle, and in rectangle APDE, AP equals to DE. But we just right now found out that AP equals to 12 units. So from this equation, 12 equals to AP equals to DE, we conclude that DE is also equal to 12 units. Here, DE is equal to 12 units. Then we defined ME as X. And then what is the value of dm? It is very easy to see that dm equals to de minus me. dm equals to de minus me, that is to say dm equals to de, that is 12 units, minus me, that is x. So in conclusion, we found out that dm equals to 12 minus x. Then we know that ASDM is a rectangle. ASDM is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, DM equals to AS. So in rectangle ASDM, DM equals to AS. But we already found out that DM equals to 12 minus x. So from this equation, 12 minus x equals to DM equals to AS. We will conclude that AS is also equals to 12 minus x. So we found out that AS equals to 12 minus x. Then in rectangle SPME, we know that the opposite sides are equal to each other. That is to say, ME equals to SP. In rectangle SPME, the opposite sides are equal to each other. That is to say, SP equals to ME. But according to our definition, ME equals to x. From this equation, SP equals to ME equals to x, we will conclude that SP is also equals to x. So here, SP equals to x. Here, from point O, we draw perpendicular to DE. So OM is perpendicular. And OM is a perpendicular, it must be a straight line. So OM is a perpendicular, it is absolutely a straight line. OM is a straight line. And we have rule number 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So, and because of the fact that OM is a straight line, so if we focus on this side of the straight line OM at point S, then the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at this side at point S? We have here 90 degrees plus angle OSA. In total, the sum of those two angles must be equal to 180 degrees. So here 90 degrees plus angle OSA must be equal to 180 degrees according to rule number 3. Here we subtract the 90 degrees from this equation, and we found out that angle OSA equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that this angle is a right angle, and because of the fact that angle OSA is a right angle, then triangle OSA is a right triangle. The green triangle is a right triangle. Then we know that AOSD is a rectangle. AOSD, here AOS, triangle AOS is a right triangle because angle AOS is a right angle, therefore triangle AOS is a right triangle. And what is the value of AO? The value of AO, A is the center of this circle that is radius is equal to 4 units. O is the center of the biggest circle that its radius is equal to capital R. Those two circles, the biggest circle and this circle, have an internal arch between them at this point. That is to say, they are touching each other at this point. So we have an internal arch, and whenever two circles have an internal arch between them, then the distance between their centers will be equal to the difference between the lengths of the radii. That is to say, it will be equal to r minus 4. So we found out that AO equals to r minus 4. AO equals to r minus 4. So I copied the right triangle AOS in the new page and we implemented the Pythagoras theorem on this right green triangle AOS. So in the triangle AOS, this is triangle AOS, we have already found out that AO equals to r minus 4. And we have already found out that AS equals to 12 minus x. And what is the value of OS? And according to our definition, OM equals to y. And what is the value of OS? You can see it very easy to see that OS equals to OM minus SM. OS equals to OM minus SM, that is to say OS equals to OM, that is y, minus SM, that is 4. So in conclusion, we found out that OS equals to y minus 4. So now we can implement the Pythagoras theorem on the green right triangle AOS. According to the the Pythagoras theorem, in the right green triangle AOS, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AO square equals to OS square plus AS square. So AO square is r minus 4 square, OS square is y minus 4 square, and AS square is x 12 minus x square. We open the brackets on both sides of equation number 1. When we get that r minus 4 square is r square plus 16 minus 8 is r. Y minus 4 square is y square plus 16 minus 8y. 12 minus x square is 144 plus x square minus 24x. We added 8r to this equation number 1, and we got that r square equals to 8r minus 8y plus 144 minus 24x plus y squared. Here we took a common factor of 8 out of those two expressions, and we got that r square equals to 8 times r minus y plus 144 minus 24x plus x squared plus y squared. Here we subtracted r squared and y squared from this equation number 1, and we got that according to equation number 1, r squared minus x squared minus y squared equals to 8 times r minus y plus 144 minus 24x. Then we actually, from point O, we draw perpendicular to BE. So this angle equals to 90 degrees and this angle equals to 90 degrees, and we defined the touching point between the perpendicular from point O and BE is point T. Then I copied the right triangle OBT in the new page, and we implemented the Pythagoras theorem on the right triangle OBT. So this is the right triangle OBT. Here, what is the value of OB? O is the center of the biggest circle that its radius is equal to capital R. B is the center of this circle that its radius is equal to 9 units. And those two circles have an internal arch between them at this point, that is to say they are touching each other at this point. And whenever two circles are touching each other internally, then the distance between their centers, that is to say OB, will be equal to the difference between the lengths of the radii. The radius of this circle is capital R, the radius of this circle is 9, and the difference between the lengths of the radii will be equal to r minus 9. So we found out that OB is equal to r minus 9. Here we have already found out M equals to x according to our definition. And here quadrilateral OMTE here quadrilateral OMTE has three right angles, 1, 2, 3, and the sum of three right angles is 270 degrees. So 270 degrees plus the size of the fourth angle, that is actually angle MOT, in total they must be equal to 360 degrees. We subtracted 270 degrees from this equation and we found out that angle MOT, this angle is a right angle, that is to say it equals to 90 degrees. And because of the fact that quadrilateral MOTE is four right angles, therefore it must be a rectangle. So we can write down that quadrilateral OTME is a rectangle and the opposite sides of a rectangle are equal to each other. That is to say ME is equal to OT. But ME equals to X according to our definition, and from this equation X equals to ME equals to OT, we've derived that OT is also equals to X. So here we found out that OT equals to X. And what is the value of BT? And according to our definition, OM equals to Y. And because of the fact that the opposite sides of rectangle MOTE are equal to each other, we get that MO equals to TE, MO equals to TE, but MO equals to Y according to our definition. So from this equation, Y equals to MO equals to TE, we will conclude that TE is also equals to Y. So TE equals to Y. And what is the value of BT? It's very easy to see from the drawing that BT is equal to BE minus TE. Here, BT equals to BT minus TE. So BT equals to BE, that is 9 units, it is the radius of the circle, minus TE, that is Y. We found out that T equals to Y. So in conclusion, we found out that BT equals to 9 minus Y. So now we can implement the Pythagoras theorem on the right green triangle, triangle OBT. According to the Pythagoras theorem, OB square equals to BT square plus OT square. OB equals to R minus 9, so OB square is R minus 9 square. BT is 9 minus Y, so BT square is 9 minus Y square. OT is X, so OT square is X square. We open the brackets on both sides of equation number 2, and we got that R minus 9 square is R square plus 81 minus 18R. That equals to 9 minus Y square. 9 minus Y square is 81 plus Y square minus 19Y plus X square. Here we added 18R to this equation, equation number 2, and we got that R square equals to 18R minus 18Y plus X square minus Y square. We subtracted X square and Y square from this equation, equation number 2, and we found out that R square minus X square minus Y square equals to, here we took 18 as a common factor and we got that it equals to 18 times R minus Y. This is equation number 2. That states that R square minus X square minus Y square equals to 18 times R minus Y. Then from point C we do perpendicular to BE. So this angle equals to 90 degrees and this angle is also equals to 90 degrees. And actually in quadrilateral QCEF, here we have 1, 2, 3 right angles, and the sum of three right angles is 270 degrees. So 270 degrees plus the size of this angle, that is actually angle QCF. In total, the sum of those four angles must be equal to 360 degrees. We subtracted 270 degrees from this equation and we got that angle QCF is equal to 90 degrees. And because of the fact that quadrilateral QCEF has four right angles, quadrilateral QCEF is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say QC is equal to CF. But CF is equal to 1 unit. It is the radius of the smallest circle. From this equation, QC equals to CF equals to 1, we will conclude that actually QE equals to CF equals to 1, we will conclude that QE is also equals to 1. So we can write here that QE equals to 1 unit, And here we join points B and C together by a straight line. What is the value of BC? BC is the distance between this circle, the center of this circle, and the center of the smallest circle. Those two circles have an external lunge between them. That is to say, they are touching each other externally at this point. And whenever two circles are touching each other externally, then the distance between their circles will be equal to the sum of the lengths of their radii. The radius of this circle is equal to 9 units. The radius of this circle is equal to 1 unit. So the sum of the lengths of their radii will be equal to 9 plus 1, that is 10 units. So we found out that BC equals to 10 units. And what is the value of BQ? You can see it very easy to see from the drawing that BQ equals to BE minus QE. Again, BE minus QE equals to BQ. So here QB equals to BE minus QE. BE equals to 9 units, it is the radius of the circle. QE equals to 1 unit. QE equals to 1 unit. So in conclusion, we found out that QB equals to 9 minus 1. 9 minus 1 is 8. QB equals to 8. BC equals to 10. So we can implement the Pythagoras theorem on the right green triangle, triangle QBC. According to the Pythagoras theorem, BC square equals to BQ square plus QC square. So BC equals to 10. BC square is 10 square. 10 square is 100. That equals to BQ square. BQ is 8. So BQ square is 8 square. 8 square is 64. So in conclusion, we found out that 100 equals to 64 plus QC square. We subtracted 64 from this equation, and we found out that here 100 minus 64 is 36, so we found out that 36 equals to QC square. We took a root out of this equation, and we got that QC equals to the square root of 36. The square root of 36 is 6, so QC equals to 6. We found out that QC equals to 6, and we know that QCEF is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, QC equals to EF. But we already found out, we just right now found out that QC equals to 6. So from this equation, 6 equals to QC equals to EF, we will conclude that DEF is also equals to 6 units. So here EF equals to 6 units. Then from point C we draw perpendicular to OM. So this angle equals to 90 degrees, and this angle is also equal to 90 degrees. And we define the touching point of the perpendicular from point C to O and OM as point U. Actually, quadrilateral UCMF is a rectangle. Why? Because it has 4 right angles, and we know that the opposite sides of a rectangle are equal to each other. That is to say, CF equals to UM, but CF equals to 1 unit. It is the radius of the circle, of the small circle. From this equation, 1 equals to CF equals to UM, we will conclude that UM is also equals to 1 unit. Here, UM equals to 1 unit. And here OC, what is the value of OC? O is the center of the biggest circle, that its radius is equal to capital R. Here so we are talking about OC, and C is the center of the smallest circle, that is radius is equal to 1. Those two circles have an internal lunge between them at this point, that is to say, they are touching each other internally at this point, and whenever two circles are touching each other internally, it means that the distance between their centers, that is to say OC, will be equal to the difference between the lengths of the radii, and the difference between the lengths of the radii is equal to capital R minus 1. So in conclusion, we found out that OC equals to capital R minus 1. And here, because of the fact that the opposite sides of rectangle UCMF are equal to each other, and therefore MF equals to UC, so MF equals to x plus 6, so UC will be also equal to x plus 6, and we have already found out that MF equals to UC, and therefore if MF equals to x plus 6, so UC will be equal also to x plus 6, and here we know that OU equals to y according to OM equals to y according to our definition, UM equals to 1, so OU will be equal to OM minus UM. Okay, OU equals to OM minus UM, OM equals to y, UM equals to 1, so in conclusion we found out that OU equals to y minus 1. We already know that UC equals to x plus 6, and OC equals to R minus 1, so now we can implement the Pythagoras theorem on the right triangle, triangle OUC. According to the Pythagoras theorem, OC square equals to OU square plus UC square. OC square is R minus 1 square, OU square is Y minus 1 square, and UC square is x plus 6 square. We open the brackets on both sides of equation number 3, and we found out that R minus 1 square equals to R square plus 1 minus 2R. That equals to Y minus 1 square, Y minus 1 square equals to Y square plus 1 minus 2Y. And x plus 6 square equals to x square plus 36 plus 12x. We added 2R to this equation, and we got that R square equals to 2R minus 2Y plus 36 plus 12x plus x square plus y square. We took a common factor of 2 from this equation, and we subtracted x squared and y squared from this equation, and we found out in conclusion that according to equation number 3, R squared minus x squared minus y squared equals to 2 times R minus y plus 36 plus 12x. Then we presented the 3 equations in one page, and we created equation number 4 that states that R squared minus x squared minus y squared according to equation number 1, that is actually equals to 8 times R minus y plus 144 minus 24x, must be equal to R squared minus x squared minus y squared according to equation number 2, that is actually equal to 18 times R minus y. We open the brackets here, and we got that actually we subtracted 8 times R minus y from this equation number 4, and we got that 144 minus 24x equals to 10 times R minus y. We divided equation number 4 by 10, and we got that R minus y equals to 144 minus 24x over 10. Here we divided both the numerator and the denominator on this side of equation number 4 by 2, and we got that according to equation number 4, R minus y equals to 144 over 2 is 72, minus 24x over 2 is minus 12x, and 10 over 2 is 5. So in conclusion, we found out that according to equation number 4, R minus y equals to 72 minus 12x over 5. Then we created equation number 5 that states that R square minus x square minus y square according to equation number 2 must be equal to R square minus x square minus y square according to equation number 3. we subtracted 2 times r minus 5 from equation number 5, and we got that 36 plus 12x equals to 16 times r minus y. We divided equation number 5 by 16, and we got that r minus y equals to 36 plus 12x over 16. This is the value of r minus y according to equation number 5. Actually, we divided the question both sides, the numerator and the denominator of equation of this side of equation number 5 by 4, and we got that 36 over 4 is 9, 12x over 4 is 3x, and 16 over 4 is 4. So in conclusion, we found out that according to equation number 5, r minus y equals to 9 plus 3x over 4. While according to equation number 4, we have already found out that r minus y equals to 72 minus 12x over 5. Then we created equation number 6. According to equation number 6, r minus y according to equation number 4 must be equal to r minus y according to equation number 5. We cross multiplied equation number 6, and we got that 5 times 9 plus 3x equals to 4 times 72 minus 12x. We open the brackets on both sides of equation number 6, and we got that 5 times 9 is 45, 5 times 3x is 15x, 4 times 72 is 188, 4 times minus 12x is minus 48x. We subtracted 45 from this equation number 6. 288 minus 45 is 243. 15x plus 48x is 63x. So in conclusion, we got that 243 equals to 63x. We divided this equation number 6 by 9. So 63x over 9 is 7x. And 243 over 9 is 27. We divided this equation number 6 by 7, and we got that the value of x equals to 27 over 7. Then we have equation number 5 that states that r minus y equals to 9 plus 3x over 4. So we put the value of x inside equation number 5, and we got that equation, according to equation number 5, r minus y equals to 9 plus 3 and x equals to 27 over 7 over 4. So r minus y equals to 9 plus 3 times 27 is 81 over 7 over 4. So we got that r minus 4 equals to, here we multiplied 9 by 7, and then we divided by 7 in order to have a common factor with this expression. And we got that 63 plus 81 is 144, and here 4 times 7 is 28. Here we divided both the numerator and the denominator of this expression by 4, and we got that 144 over 4 is 36, and 28 over 4 is 7. So in conclusion, we got that according to equation number 5, r minus y equals to 36 over 7, and x, according to equation number 6, is equal to 27 over 7. Then we, according to equation number 2, we've already found out that r squared minus x squared minus y squared equals to 18 times r minus y. R squared minus y squared is equal to r plus y times r minus y, according to the algebraic identity that a squared minus b squared equals to a plus b times a minus b. So, and then we added x to this equation. So in conclusion, we got that r plus y times r minus y equals to x squared plus 18 times r minus y. Here we substituted r minus y by 36 over 7, and we substituted x by 27 over 7, and we got that r plus y times 36 over 7 equals to 27 over 7 times 27 over 7, and 18 times r minus y is 18 times 36 over 7 equals to r minus y equals to 36 over 7. We multiplied this equation by 7, and we got that r plus y equals to 36, so 7 will get cancelled, and we have here 27 times 27 over times 7 times 7, so 1 7 will get cancelled, and we left only with 27 times 27 over 7. Here 27 18 times 36 over 7, here 7 will get cancelled, and we left only with 18 times 36. So here we divided this equation by 9, and we got that 36 over 9 is 4, and here 27 over 9 is 3, and 18 over 9 is 2, and 2 times 36 is 72. So in conclusion, we got that 4 times r plus y equals to 3 times 27 is 81. We multiplied 27, multiplied 72 by 7, and then we divide it by 7 in order to have a common factor with this expression. Here 7 times 72 is 504. So we got here 4 times r plus y equals to 81 plus 504 over 7. 81 plus 504 is equal to 585, all divided by 7. So we divided this equation by 4, and we got that r plus y equals to 585 over 27, and we already found out this is according to equation number 2, but according to equation number 5, we already found out that r minus y equals to 36 over 7. Here we multiplied both the numerator and the denominator by 4, and we got that 36 times 4 is 144, and 7 times 4 is 28. Then, so according to equation number 2, r plus y is equals to 585 over 28, while r minus y according to equation number 5 equals to 144 over 28. We added the equation number 2 to equation number 5, and we got that r plus r is 2r, and y plus minus y is y minus y, that is actually equals to 0. So in conclusion, we got that 2r equals to 585 plus 144 over 28. So 2r equals to 585 plus 144 is equals to 729, all divided by 28. We divided this equation by 2, and we got that the radius that we are looking for, that is to say the radius of the biggest circle, is equals to 729 over 56 units, or in terms of numbers, it's equals to 13.018 units. I repeat again, the radius of the biggest circle that we are looking for is equal to either 729 over 56 units, or we can represent it as 13.018 units. Okay, thank you very much.